So far, we've looked at how to build up basic functionality using I/O and Haskell, and we looked at some of the get the most significant number functions from the last time, and we used them to return from monadic instances values that could then be manipulated based on user input. So, in this video, what I'd like to do is show you how to build a simple I/O function that would find the largest value or the largest string in a list of strings. To do that, we're going to need to get in a list of strings from the user. Then we're going to need a function that returns the largest element of that list. And then we need a main method to run it all. So that's the way I would suggest building it. We do one method, which returns a list of strings, which we get from the user. A second method, which is a non-I/O function, which just finds the largest value in a list. And then finally, we have a main method, which just calls these functions. So this is one thing that we can do to make our I/O functions a little bit more readable and a little bit easier to build. Just build simple helper methods to do some of the repetitive work for us. So let's first build a GetList function. Now, in this function, all we really want to do is take in strings until the user let's say the user enters the empty string. We'll call that the end case. That's the case where we stop. So what we want to do is off the bat, we want to get x's, well, let's call it x, from user. So that's just going to be get line. So if we have a string from the user and we want to know if it's the empty list, if it's the empty list, we terminate. If it's not the empty list, we continue. So I'm going to say if x is equal to then we want to do something. If this is in an if-then statement, we're going to have to return something of the same type. So if this is empty, what we're going to do is return the empty list. And this is going to help us build up the list, just as we would in any other Haskell function. When we get to the end of something, we want to return the empty list. And even though the syntax is a little bit different, it's not different when we're working in I/O. Else, there's a couple of things we want to do. One, we want to build up a list recursively, and we want to return the final list. So what I'm going to say we do is, we return, or we have a recursive call to GetList, which will get the rest of the strings for us. We'll concatenate onto the value x that we have so far and return the whole thing. So what does that look like? All we do, x's comes from get list, and then we'll return x cons x's. So we take in the first element, that goes at the front of the list. Before that, we recursively call. Eventually this thing, x's, will be built up by the recursive calls until we have the whole list, which we just returned. So let's load that in and see if that works. Make sure I've not got any errors. So far so good. So we'll do get list, and I'll just mash keys. So let's do a big one, do a smaller one, slightly longer one, and then let's do a massive one at the end. And if we hit enter, and enter again, we get that back as a list of strings. So this is one simple way in which you could build up a list of values using I/O. So next, we would want to find the largest element of the list. So let's do a simple find largest value method. So what I'm going to say we do is $r, and what we're going to do is /x, and this is going to go to if length, because I know x is going to come from the front of the list, and the list is a list of strings. So if length of x is greater than length ac, then x becomes the new accumulator, else we keep ac as the accumulator. And we'll start with the empty list. So that no matter what string we get, it will always be emptier than the empty list, or longer than the empty list, because the empty list has length 0. So in the first instance, we'll replace that with the first string we encounter in the list, and then we'll just keep going until we find the largest. And we'll call this with x's. And that should be fine. So let's try this. So we'll do $r, and let's come up with just mash keys again. And let's just do a short list. So this value here should be the largest value in the, not $r, we want to do find val. And we'd want to reload first as well. Let's hit enter there, and let's do reload. And then we can do find val, and we can do this. And there we go. So we know that this is doing a fine job of finding the longest value in the list. So now that we've got some of this functionality down to a couple of simple steps, what we can do is create a main method which will call these functions, and they will handle most of the work for us. And this will mean that our main method is quite short and quite concise. So let's do main equals do, and we'll do some printing just to, so we'll put a string saying enter list of strings, something like that, so that the user knows what they're doing. And then we'll do put car, just to make sure that we have another empty line. And then we want to get the list. So let's say that x's is going to be GetList, and then we want to just return whatever the largest value in that list is. So we can do return find val x's. Now, because lists have an instantiation of the return type, we can use this absolutely fine. For some of your own defined types, you might have an error just trying to return a value because it doesn't necessarily know what that is. For example, if we define binary trees and we didn't give an instance, we might not be able to use that here. However, for the list structure, this is absolutely fine because Haskell has this built in. So let's save this, reload, call main, enter a list of strings. So let's do the massive, shorter, and we can just keep going like this, mashing keys away, and let's hit enter there. And that is the longest string in the list, as you can see. So this is just a simple exercise to show you how you would build up a list using IO and Haskell, and you can see the structures not too dissimilar to things that you saw in the previous example. And this is also to show you how you might use something that's not an IO function here. This is not an IO function, but the return function is handling that for us. It's giving us something of the IO type because that's what return does in this instance. So that's everything I wanted to show you today. I hope you found this useful. If you have any questions about this, of course, you're more than welcome to get in touch. Thanks.